This video is about getting to know your friendly neighborhood parabola. So there are a few things that you should do whenever you meet a parabola around town, like you do. And the first thing that you should do is you should ask it about its roots. Hey, parabola, where are your roots? Where are you coming from? And here's an example of a parabola, right? Here's an example of a quadratic function. This could also be written as maybe f of x is equal to x squared minus 6x plus 8. And so I might want to find its roots. Now remember that the roots are the x-intercepts. They're where y, the y value, the vertical, is 0, right? We haven't gone up or down at all. So what we're going to do is we're just going to take this, we're going to look at where the y is or where the f of x is, and we're just going to replace that with 0. So 0 is equal to x squared minus 6x plus 8. So now I'm going to take a look at this quadratic, and I've got 8x squared, so I need some magic numbers that add up to negative 6. And so they've got to both be negative, right? Because it's adds to a negative but multiplies to a positive. So how about negative 4 and negative 2? Okay. Now those of you who remember that this is an a equals 1 will be able to jump right into the solution, but let's pretend I forgot that for a moment. So I could do x squared minus 4x minus 2x plus 8. So I'm just splitting that central term. And now I'm going to do a little grouping. So I've got 0 is equal to x squared minus 4x plus, second group is negative 2x. Remember the sign goes inside with it, plus 8. And so looking at that, I've got a common factor of x here, leaving me with x minus 4. And I've got a common factor here of negative 2, leaving me with x minus 4. So my two factors are x minus 4 and x minus 2. Again, if you remembered that when a equals 1, you can jump straight to that trick. You'll notice that it's x minus 4. X minus 4 is the first magic number, and x minus 2, negative 2, is the second magic number. So now I'm going to take those and I'm going to set these both equal to 0. So 0 is equal to x minus 4 and 0 is equal to x minus 2. And so solving, I'm going to get that x is equal to 2. And here, x is equal to 4. So what these mean, remember, y was 0 for these. So this means that I've got 2 points. One point is 4, 0. That's one of the x-intercepts. And one of the x-intercepts is 2, 0. I'm going to actually write these in the other order so that they're closer to where they belong, right? So 2, 0 and 4, 0. So now let's take a look at this graph. This is a graph from Desmos of this function. Notice where that first root is. Yeah, exactly. It's at the point 2, 0. And this second root is at the point 4, 0. So knowing where its roots are can give us some really important information. Okay, so once we've learned about the roots of a parabola, now we might want to know, what's at its heart? What's at its core? What's central to this parabola? See what I did there? Central to this parabola. So remembering that our roots here were 0, mixed that up. That should be 2, 0. It's a x-intercept, not a y-intercept. So our roots are 2, 0 and 4, 0. We want to find the axis of symmetry, right, for this parabola. And so the axis of symmetry is going to be the average of the two x-intercepts. So we're going to take the two values for the x-intercept, 2 and 4, and we're going to average them. So there's two numbers, so we'll divide it by 2. So x is equal to 6 divided by 2. So my axis of symmetry is at the average of these two roots, or x x is equal to 3. Look at that. That line right there is the line x is equal to 3. So now we know its center, we know its axis of symmetry, we know that it has these two roots on either side. So what else do we want to know about this parabola? Well, we know that the axis of symmetry is x equals 3. Right? And I'm just going to go ahead and label these again. This is 2, 0, and this is 4, 0. Okay. But I want to know what this bottom point is, right? I want to know what this vertex is. So I know that the vertex is on this axis, right? Because the vertex is always on the axis of symmetry. It's on this axis where x is equal to 3. So, but I wish I knew what y was when x is equal to 3. Well, could I find out what y is when x is equal to 3? What if I just evaluated this equation when x is 3? So that's going to give me 9 minus 18 plus 8. And that would give me negative 9 plus 8, or negative 1. So when x is 3, y is negative 1. So my vertex here is at the point 3, negative 1. And is it a maximum or a minimum value? Well, again, look at the leading coefficient of the quadratic term. That's what's called our a value. And if a is positive, it's a smiley face. And of course, we're looking at the graph, so you're like, obviously, Kate, this is a minimum value because it's a positive parabola. But, you know, eventually I'm just going to give you the equation and you're going to have to draw the picture on your own, right? So once we know all of these pieces, right, once I know where the vertex is, once I know where the axis of symmetry, once I know where the roots are, and once I know whether it opens up or down, now I can get to a place where I pretty much know where this parabola is going to go, and I can give it a nice graph. Okay. I'll post a second video with another example if you're interested in more, or otherwise jump right into the practice. Great, thanks.